So we are going to solve a little bit of exponential and log equations today. I haven't decided if I'm separating them into two standards. I need to make up my mind about that for the quiz, or if we're going to leave it in one. But there are 4 strategies on this worksheet. The first strategy says if a problem has a single power of x, like even an x squared, okay? This is no different than we've been doing all year. You isolate the power, and then you need to undo that power, but we might have some weird powers that we might have to take a reciprocal of. So again, thinking with your Algebra 1 brain, what do we need to do first to this problem? Yep, and we get, whoa, great, my pen's not gonna, this is not gonna work. Came and fixed it, or so he told me. On the fly, Hofbauer switches tablets. Let's see if this one works. Or not. Okay. We're dividing, come on, you can do this. We're dividing both sides by 15, which gives us what? Okay. Now, this is a weird radical. Can anybody remind me what it means? 2/3 power means the cube root of something squared. Good job. But we can deal with this all at once. We could undo it in 2 steps, but we can deal with it all at once if we raise each side, because we're going to get a weird answer anyway, or not. I don't think this one's going to come out okay, but we can raise each side to the 3/2 power, because what happens when you have a power to a power? Do you remember? If we had an x squared to the 5th, we got an x to the 10th, yes? So what's this going to do when we multiply by the reciprocal? It's going to become 6/6, which is 1. So this is just going to be an x to the 1st power. Now, over here, you're welcome to use your calculator, but when we do 4 to the 3/2, it means 4 cubed and a square root. We could square root first. What's the square root of 4? 2, and then 2 to the 3rd power is, did anybody type it in? With a 4 to the 3/2 power? Okay. So what do you want to try on the next one? Divide by 3, which gives us x to the 1.2 equals 19, maybe? Did I get that right? Okay, and then can we do the reciprocal of that? We could change it into a fraction and do a reciprocal, but can't we just do 1/1.2 and it'll work? Anybody know what 1.2 would be as a fraction? 1 2/10 would be 12/10 or 6/5. So the reciprocal would be 5/6, but it just doesn't matter. We're going to use our calculator anyway. So 1/1.2 works. Anybody tell me what crazy decimal you get there? Let's try to go 3 places for accuracy. (19 to the power of) oh, my calculators. 1 divided by 1.2, all up in the power, 11.631. Everybody getting that? Anybody have a question? Need me to push it on the show it on this calculator? I can't talk either. If we were to plug it back in, the less decimal places we use, the less close we're going to get to that answer. Let me show you what I mean. Can you type 3 times 11.6? If you just put 11.6, go 3 times 11.6 to the 1.2. Can you try that on your calculator? 3. Your calculator will take care of doing it first. You can, yes, you could do 11.6 to the 1.2 and then times 3. But the calculator will do it in the right order. I unfortunately cannot type. I got 56.8, yes? Okay. If we put more decimal places in, we'll get closer to checking it to be 57. Does that make sense? The more places we go, the closer it'll get. All right. Moving on. Is there a third one up there? No? That's it for strategy A? Okay. Strategy number 2 here is if a problem has a single exponential, which means variable in the exponent, guys. You need to know that vocabulary. It's an exponential when the variable is in the exponent. You want to isolate that term and then take the log of both sides. And I'll show you, but it doesn't matter. As long as you do the same base on both sides, it does not matter. So you can do base 10 or base E because those are the two that are easiest to get on your calculator, right? We could do another base. We could rewrite, because our calculators do log-based problems, but that's a whole bunch of extra typing that. All right, isolate first though. So what do we need to do first? I can't stress enough that you cannot multiply 50 times 3. Does everyone see that? Because students do that even weeks into this, and I just want to cry. You cannot multiply 50 times 3. Okay, we have to divide off the 50. And anybody helping me? Okay. Now it says once we've isolated the exponential or the thing that has an x, we're going to take the log of both sides. Anybody have a preference what we do on this first one? Do log maybe? We're going to write this. Okay, then what? Why did that help us? Anybody know? What is this? Where does it allow us to move that? Yes. Now it becomes 2 times x times the log of 3 equals the log of 25. Now, I'm going to do that in 2 steps. You could do it all in 1 step, but you'd need some parentheses. I'm just going to divide the log over to the other side first. So that I end up with 2x equals some decimal, and then I'll divide by the 2. You could multiply the 2 by the log and divide it over there, or you could divide by the quantity 2 times the log of 3. But you would need parentheses. So I'm just going to go this route. Now, this is where I just want to show you that we did log. Was it 25 divided by what? The log of, I forgot what the number was, 3? Okay. Does everybody see that that's exactly the same thing? It doesn't matter which kind of log that we did of both sides, okay? Now, when I said you would need parentheses, I really don't suggest you do them this way. But if you did the log of 25, and then you said I'm going to divide that by, and you did both 2 and the log of 3 in the denominator, this is the answer we're going to get, because we're going to take what we got up here, yes? And isn't that 2x? On our paper, we have equals 2x. So we're going to divide that by 2. We could have done it all at once, but I'm not a fan. I just think we're going to mess up our parentheses, okay? So what was the 2x? 2.9 something, guys? Absolutely. Yeah, that's what we're essentially doing. On a quiz, make sure you show your work just for partial credit. You know what I'm saying? If you type something wrong, then I might catch it. This was what, 2.9 something? Guys, 2.9299. 2.9299, and then you divide it by 2. But yeah, you would just do it all in your calculator. And then we got 1.465, yes? All right, let's see if we can do the next couple a little bit faster. So tell me what to do first. Divide by 6.6. Now, this is where Hofbauer gets real lazy. I don't even divide that. Because what's the next step? We have this isolated. Anytime there's an x in the exponent, you're going to take the log of both sides. Let me say that 3 more times. Anytime the x is in the exponent, you're going to need to take the log of both sides. Anytime the unknown is up in the exponent, we're going to take the log of both sides. Got it? So I just didn't bother to type this in yet because I need to take the log of both sides. Is it okay if I do natural log this time? And where's that x going to move? It's going to move to the front as a multiplication. And I have the log of 0.8 over 6.6. I just didn't bother to type it yet. And then I'm going to divide both sides by what? The natural log of 0.5 or log, it doesn't matter. But that's going to give me x. But I didn't bother to type because I didn't want to have decimals to have to round along the way. Are you seeing what I'm saying here? And I just didn't have to touch my calculator yet. Okay, now some kind of log of 0.8 divided by 6.6, then close that parenthesis, divided by the same kind of log of 0.5. 3.044, anybody? Anybody not getting that? Did you not get that, Samantha? All right. 0.8 divided by 6.6, and then divided by, you do have to do the log again. The log is not multiplication. I had a couple people on the quiz give me, oh, this was supposed to be 0.5. The log is a function, remember? It's not like the log times something. So when you put a log over a log, they don't divide out and cancel or anything crazy. It's a function. We good? Now did you get it? Anybody stuck? Yeah, 3.044. Adriella, got it? No? Come look. Try the next one, guys, because it's the same stuff. Got nothing. Okay, try it for me. Whoa, whoa, whoa. What are you doing? You can't type an X in ever because it has a number stored in it. Yep. We're trying to get the X. Okay. We're doing this stuff. So we need to type this. Okay, better? Because this side we just divided so that that canceled off and then we have X in place. That makes sense. How far did you get on the next one? Get an answer? What kind of log do we want to do this time? Yeah, let me see if I can put this on a new slide quick. You can do this one, you said? Okay, so what'd you do first, Jada? Which gave you, when you carefully typed all those zeros? Okay, now base E means it would be a really good idea to take what kind of log? A natural log, because, do you remember the properties we used yesterday on the quiz? The natural log of E is going to be what? Yes. So the natural log of E is going to be 1. So what are we our only step remains to do what? If this is 1, we got to divide by that 0.5 and we'll be good. And make sure you're closing your parentheses before you divide. If we did base 10, then we'd have to do the base 10 log of E, which would just be disgusting. Was it 600? And then divided by 0.5? $12.794, anybody, or did I type something wrong? Adriella, yes? Okay. Number 3, this is when you have a log in the equation. When you have a single log, okay? When you have a single log, you're going to isolate the log expression, and then I say you're going to rewrite it as an exponential sentence to solve. Some teachers say you're going to exponentiate both sides. We'll see if this looks familiar. What is the base on this question? 10. This is a base 10 question. So remember this, log base B of a number equals the power B to the P equals N, yes? Okay, so this means 10 to the what? The answer to a log sentence is the power. So it's 10 to the third equals 2x plus 20. And then 10 to the third is 1,000, and then we're at an Algebra 1 problem. Can you finish quick? Come on in, Antoine. We're getting pictures done? Oh, I thought I saw you in the hall earlier. They came by with a pass. Are you getting a senior picture done at some point today? Okay. All right. Backing up a minute, some teachers teach it this way. They would say it said the log of 2x plus 20 equals 3. This is a base 10. So then they say we're going to exponentiate. In other words, we're going to put each side in the exponent. Does anybody remember seeing their teacher do it that way last year? What? Yeah, I'm not a fan because it feels like magic. Rewriting it like this makes sense to me. But if you do that, this takes care of this, and you just end up with 2x plus 20 equals 10 to the third over here. I'm going to continue to do it this way, but I can try to show you a little more if anybody just needs to tie this to the way their teacher did it last year. But what do we need to do first on the next one? Algebra 1 brain. Yeah, just divide by 3. So we have the natural log of x plus 2 equals 2. Okay, what's the base this time though? E. So how are we going to rewrite that? This sentence, the natural log of x plus 2 equals 2, means e to the power of 2 equals x plus 2. These are the kind of questions that Delta Math will say give an exact answer. Does anybody know what that exact answer would look like? In other words, they don't want to type in the calculator. How do you get the x all by itself, guys? Just subtract the 2. So e squared minus 2 equals x. That's the exact answer. All right, if we want an estimate, I always use the natural log key to get e. So you would do second, and then the natural log to get e, and it's going to bring you up to the little power there. Was it e squared? And then we have to arrow to the right to get out of the box, minus 2, because Hofbauer can never do that right. 5.389, anybody else? But Delta Math will sometimes ask you to do those kind as an exact answer. All right, is there one more in this strategy? No, that's it? Okay. Strategy 4, when you have multiple logs. This is the one I'm scared of because you did not do well on the property of log section. And guess what the first step is? To combine until you have a single log or a single log on each side. Okay, if a problem has several log expressions, try to compact them using the appropriate rules and then solve using one of the above patterns. It says, what does multiplying logs mean? What does adding logs mean? Multiply, condense them into a single multiplication. So this would be the log of, how would we condense that? 2x times x. I'm just going to write it that way. We can write it as 2x squared, but we're adding means we condense and multiply. I just want your notes to know where that came from. Now we're down to a single log. Can you look back at the previous strategies? Which strategy would this be? The one right above it, yes, it's the only one that had logs in it. How do we rewrite this? We could. Yes. Jada wants to know, could we write this as 2x squared and then move the 2 to the front? Actually, no. Because the squared is not on the whole thing, Jada. It's only on the x. Yeah. I think we should just do the rewrite thing. What's the base? So we have 10 to the power of 3 equals, now can we rewrite it as 2x squared and you'll know where that came from? Okay. What are we going to do next? We're going to divide by 2. You can figure out what 10 to the third is and then divide it by 2. I think we're going to get 500. Is that working for anybody? 10 to the third is 1,000 divided by 2. All right. Yep, it's still squared, so we have to. Okay, now, what do we have to remember when we square root an x squared? Plus or minus, okay. Back up to the very beginning of this problem. Can you take the log of negative square root of 500? You cannot take the log of a negative number. So one of these is called, anybody remember the big word? When it doesn't work? Yeah, we can't have extraneous solution here. We have a negative square root of 500 that is going to get thrown in the garbage. Okay? Must be positive to take a square root. I'm sorry, to take a log. Just writing that for the benefit of your notes. But so we have square root of 500 is x. If they made us have an exact solution, simplifying radicals, that would be 10 square roots of 5. Everybody okay with that part? Or if a decimal was okay, if it just said on Delta Math, do the decimal, you could just do square root of 500. was 22.361. Yes, no? Okay, a lot of steps. What do you want to do on the next? Go ahead. Say that again. Yes, 10 root 5 is fine. I just don't, some on Delta Math say exact, some say nearest 10th, nearest 100th. You just have to read what they want. All right, on this problem, there's a bunch of different ways we can do this. I'm going to just leave it the way it's written for a minute. In other words, I'm not going to move anything left to right. What can we do with that too, guys? We can make it the natural log of x. We can move it up as an exponent, which we don't need those parentheses, by the way. All right, what does minus mean? Divide. So if we combine these using our properties of logs, this is the natural log of an x squared over 3. Did I lose anybody? Now, what is different about this question and the other one? This one has a log on both sides. Guess what? There's a property that says, I have it on the other one that I have open, I think. What's the name of it? It's the very first thing on this notes. Here we go. One-to-one property of logs. If the log base b of x is equal to log base b of y, then x must equal y, okay? Which is a big fancy way of saying that the only way that this is equal to this log is if what's in here is equal to what's in here. Does that make sense? Yes. Basically, we're going to say if these two functions are equal, then what they are taking the log of must be equal. We're not dividing the log off each side, okay? I just need to be clear on that we're not dividing, but we can say we're going to get rid of the log on both sides and say what they were taking the log of is equal. All right, can you finish? What would you do to get rid of divide 3? Multiply by 3 on both sides, which would leave x squared equals 36. Normally we'd square root and get plus or minus, but can we have a negative? Now it's really weird. If we'd started out with an x squared, we could have had a negative, but the original problem, because you would square it first, but the original problem said 2 times take the log of x, and you can't take the log of a negative number. So the only solution is 6. There are times when you will have a negative depending what expression you're taking a log of. Is there another one on this section? That's it? Okay, go to the bottom. I'm going to give you, how many we got? 4 of them? So I should give you 4 minutes. See if you can do those 4. Using one of those strategies above, feel free to talk to your neighbor. And I'm going to try to find that other worksheet I wanted to do a couple problems off. Look at the examples up above if you get stuck. Anybody stuck on one they don't know how to start? Oh, I'm recording this. That's going to be a boring video, huh? All right, how'd we do? That's not probably 4 minutes, but divided first. Then what did you do? I left it alone because I'm too lazy to mess with it. Base E means what? We should take the natural log. Why? Because the exponent was the variable, right? And you can simplify this one. I was just not typing my calculator yet. Move that out front. What happens? ln of E is 1. So we need to divide by 0.2 and we'll be done. So if I could type. 4.581, anybody? Okay, what's different about the next one? In words, what is different on this one? Good job. The x is not in the exponent. So to get rid of a 1/4 power, we do to the 0.4 power, I can't talk. 1 over 0.4. 70 divided by 4, and then that whole answer to the 1 divided by 0.4. 1281.136, anybody? Is anybody not getting that? I went fast. This is property 1 or strategy 1. And I'm actually not sure that there's any of that in Delta Math. Okay, what about this one? This one should be super easy, but what do you have to do? Yes, adding logs can be combined into a single multiplication, so x times 3 or 3x. And then what? Yeah, we can get rid of this because it's exactly 1 log equal to the other. That only works. That only works if you have 1 log equal to 1 log. It does not work. You cannot randomly get rid of all the logs here and say x plus 3 equals 48. That doesn't work. 3x equals 48, and then is it 16, guys? Okay, what do you want to do first on this one with your little algebra 1 brain? Divide by 3, so we have the log of x over 2 equals 2. Now there's one log, so we have to do what? Rewrite it, and it's currently base 10 squared, perfect, j to x over 2, and 100 equals x over 2 means we need 200. We need to multiply over there. All right, do I have more baby base problems on here? I do, now that we're out of time. On the next sheet, there are what we call, Miss Abruzzo calls baby base problems. I'm just gonna set up a couple here. Looking at this number 4, you have the wrong pen. Is this on the next page? You have this number 4. To combine, when you had an x squared times an x to the 5th, you ended up with an x to the 7th. Everybody remember that property? So we're going to do 8 to the power of k squared plus k plus 2k minus 9, because these are both powers of 8, equals, what are we going to do with this side? 4k plus 11. Now, if these are both the same base, what do you think we can do with the exponents? They have to equal each other. Now, this one is a k squared plus 3k minus 9 if I combine them. This one is a 4k plus 11. Has a squared, so what do we have to do? Well, but can we factor it yet? It has to equal 0 first, okay? Can I just stop and do one more? What would you do to one like number 6? Anybody know? If we could see number 6. They have to be the same base, okay? I'll do more of these tomorrow, but they have to be the same base. What base can those both be? Does anybody know? Is 64 a power of 4? Remember the tan sheet? It is. This is 4 to the 3rd would be 64, and the denominator, that was a question on one version of the quiz yesterday, right? Yeah, so it's 4 to the negative 3 equals 4 to the a squared minus 4. So now we can take those exponents and set them equal, add the 4 over here, and we would get a equals plus or minus 1. Is there any reason a can't be negative if the first thing you're going to do when you put it back in is square it? No, so this one you get to keep both of those. All right, I know I went really fast on that baby base part, but you will get more practice on those tomorrow. All right, the assignment, I think, is delta math.